March 8th. Okay. Yeah, possibly 8 March होगा, right?
Recording in progress.
Right. Good evening and welcome to, I think, day 11 or day 12 of this program. So, in the last class, we discussed about, we finished module number 5 and we started module number 6. And basically, we covered article 130 and chapter number 2. So, chapter number 2 is quite generic. In chapter number 2, it's most of the questions or the concept is related to that you will be doing maintenance as per the manufacturer requirements. So what manufacturer suggests you, how often you have to maintain your electrical equipment. It was related to rotating machineries, VFDs, control circuits, cables, etc. So basically we have to maintain it as per the manufacturer recommendation. So chapter number 1 and chapter number 2 constitute around 90% of your exam content. This we also verified from the handbook, and we went through the complete handbook in the last class. The last 10% of the course and the exam domain 5 is focused on chapter number 3, safety requirements for special equipment. Again, there is not much concept in this chapter. You have to highlight most of the things, and you have to keep those things in your consideration, that what will be the energy level when you are talking about the lasers, equipment, batteries, or capacitor banks, and etc. So for example, if I give you some examples here, what could be some of the possible questions related to this chapter could be, for example, in batteries, it will ask you about its energy thresholds. So for battery, energy exposure levels shall not exceed those identified in the following list unless appropriate controls are implemented. For AC, 5 volts and 5 milliamperes, and for DC it's 100 volts. So these type of the things you will going to find for your battery, for your lasers, as well as for other part as well. Here in lasers equipment, it talks about the voltage and current. So 5 volts AC and 5 milliampere, and for DC 100 volts DC and 40 milliampere. So those are basically the boundaries they have already defined. So we have to take care of those things. So the safety requirements for special equipment, if you look into chapter number 3, you will going to find article 300, which is general. So this chapter is related to special equipment. So most of the requirements which we studied in chapter number 1 are not applicable, or if applicable, they need to be modified. So for example, for electrolytic cells, if a person is working in an environment where there are electrolytic cells, so the R flash boundary and the shock protection boundaries are not applicable, or are not calculated as per the chapter number 1 requirement, but there are different methodology which are established for that particular working zone need to be considered. 70 does not talk about what are those methods, or what are the calculation method which we need to take into the consideration, but it says that the chapter number 1 requirements are not applicable here. Similarly, then article 320 talks about batteries and battery rooms. Article 330 it's about lasers. 340 it's about power electronic equipment. 350 about research and development laboratories, and 360 about the capacitors. So Article 300, the chapter number 3 covers special electrical equipment in the workplace and modifies general requirements of chapter number 1. So it's basically modify the general requirements of chapter number 1. So all the requirements of chapter number 1 might not be applicable here. Chapter number 3 covers additional safety related work practices necessary for practical safeguard employee against the electrical hazard associated with the special equipment and process that have not been excluded. So chapter number 3 will going to cover some additional safety related work practices which are necessary to provide protection to the employees who are working around special equipment. So those might not be covered by chapter number 1. So these are specific for chapter number 3. Overall responsibility, the employer shall provide safety related work practices and employee training. The employee shall follow those work practices. Going to Article 310, safety related work practices for electrolytic cells. So electrical hazards in electrolytic lines may differ from other workplace electrical hazard. The approach distances which we have gone through in section 130.4 do not apply, nor does the arc flash analysis as specified in Article 130 is applicable. Approach distance, arc flash boundaries, and safe work practices are specific to the characteristic of a particular cell line zone. So what is this specific is there? This is not mentioned in 70, but it negates that you cannot use Article 130.4 and 130.5 here for the calculation of the approach boundaries. So we know that for the electrolytic cells, you cannot establish an electrically safe work condition until and unless the electrodes are removed or the electrolytic material is or the liquid or the fluid which is inside those cells are there with that is drained out. If both are present, you are not being able to establish an electrically safe work condition. So that's why most of the work related to the electrolytic cells are being performed on the live system. So only qualified person shall be permitted to work within the cell line working zone with the training. Unqualified person may enter the cell line working zone to perform a specific task when advised by the designated qualified person. So what will be the limited approach boundary, restricted approach boundary? Those are not here, but there are in the electrolytic cell there is a concept of cell line working zone this here. Article 320 you will going to find related to batteries and battery rooms. So 250 in Article 250 we talked about the batteries and battery rooms maintenance perspective. Here it is related to hazard. So what are the hazard associated with batteries and battery rooms? So there is an arc flash hazard, there is a shock hazard. In addition, in the batteries and battery rooms, due to hydrogen explosion from open flame or smoking, due to the presence of different type of the gaseous mixture, there is a chances of explosion are there. So that's why ventilation is provided within the batteries and battery rooms, and the maintenance of those ventilation system is the responsibility of is covered in Article 250. Then there is a chemical burn from battery and battery electrolyte. Those are hazard associated with the batteries and battery rooms. So there are 4 hazard associated with batteries and battery rooms. So you have to keep these things in your mind. Protective equipment must be made available to authorized personnel performing battery maintenance. Both electrical and chemical hazard must be considered. So when we are dealing with batteries and battery room, we have to take into the consideration different type of the hazards, including the electrical as well as the chemical hazard. The specific proactive equipment requirement depends on the type of the electrolyte, whether those are liquid, solid or immobilized, portable or stationary eye or body wash are required for liquid electrolyte. Again, in Article 250, we saw that there is a requirement for maintenance of portable and stationary eye and body wash equipment. What are some of the safety things which are related? One is the energy threshold. So Energy exposure level shall not exceed those identified in the following list. So if you are working on a battery system, and if you are, and it is being converted to, it is basically converted to inverter side, that means on the AC side, so it should be 50 volts and 5 milliampere. It's controllable. If you are working above that, then you have to apply some appropriate controls. For the DC side, 100 volts, you can perform those jobs safely. Article 330, it's about the lasers which we are using in industries, or the lasers which we might be using in hospitals and other area. So what safety measures we need to take when we are engaged with lasers and its associated equipment. So safety related work practices for maintaining lasers and their associated equipment. Laser require work practices and specialized equipment and training to protect against hazards such as high voltage, because it is converting low voltage into high voltage within those laser equipment. There is an ionizing radiation is there. Biological effects on eyes can be caused. Capacitor banks, which are part of the laser equipment, there is a chances of explosion of those capacitor parts. High sound intensity from pulse laser, those are also hazardous thing which is covered when we are dealing with lasers and its associated equipment. For power electronic equipment, there are different type of the power electronic equipment which are being used in our industries. It may be we might be using power electronic equipment in our building plant, or we might be using those things when we are in VFDs, for example, or in inverters and converters as well. So power electronic equipment can be found in many work settings, electric arc heating and other part. So those are also considered as an special equipment, because the chances of there are different type of the hazard associated with the utilization of power electronic equipment. This is covered in Article 340.4. So describe hazard associated with power electronic equipment, like high voltage within the power supply. So if we are using the power supply, which is providing low voltage, might be providing low voltage at the output, but the high voltage might be present there. Radio frequency induced high voltages burned from radio frequency fields, ionizing radiations, radio frequency radiation hazards from number of communication and medical devices. So these are hazard associated with the power electronic equipment. You just have to keep in consideration, because in exam the Q&A related to these topics will be straightforward. They won't be, because there is nothing much about checking the concept, why it is, and how you can perform something different. Article 350 is related to research and development laboratories, R&D labs. So research and development laboratories are different from normal work practices, because in research and development laboratories, you are testing something which might not be proven before. So in research, and right now we might have a highest voltage available, 500 kV or 800 kV. Maybe in some part of the world where the research and development is being carried out, and the highest voltage which they might be testing might be greater than 1000 kV there. So the hazard associated with the research and development laboratories are different as compared to industry, because in industries there are proven things have been proven, and we know about the hazard and its associated risk, and can apply the control. But in the research and development laboratories, you are testing new things, you are experimenting. So there could be different scenarios here. So Article 350 describe unique condition that may exist with electrical installation in laboratory and research and development facilities. So here comes the concept of Electrical Safety Authority. Okay, so ESA is basically the person who is knowledgeable in the NFE 70 standard. and he knows about the electrical system requirements of research and development laboratory. So ESA, which is an electrical safety authority, could be a person, it could be a committee, it could be an individual, or it could be a group of people. So this person is responsible for defining required PP when calibrating or adjustment requirement installation inside equipment or control cabinet surrounded by those electrical hazards. So this person will be responsible for advising what type of the PPs are required in order to perform the job. So the ESA role is same as the role of AHJ, which is defined in chapter number 1. But the AHJ role is for authority having jurisdiction role is for industries. ESA role is specifically for research and development laboratories. So ESA should be knowledgeable with the NFPA 70, knowledge with the electrical system requirements and applicable to research and development labs, define required PP required, and similar to an AHJ in some form. In addition to the ESA, Electrical Safety Authority, a competent, not just a qualified person, is required to oversee the laboratory and to ensure that employees follow the electrical safety related work practices and controls as documented in the electrical safety program. So the competent person is not just a qualified person, but he is also responsible. He is responsible to ensure that employees are following the electrical safety related work practices. So what is the difference between the ESA and the competent person? ESA is the one who will be providing requirements or details, what need to be done, what need to be, what PPs need to be selected, etc. and etc. The competent person will be there for assurance and governance that those things are being implemented in the industries or not. Right. So equipment in labs is often manufactured solely for use in these facilities. NFPA 70 can't create specific rules that apply to individual piece of equipment. So instead, put limits on amount of energy use and shutdowns requirement. What are some of the threshold energy related to the task being carried out in the laboratory? So if the task is being carried out on the AC 50 volts and 5 milliampere, it's okay. Beyond that, we need to put some additional measures. If the task is being performed on DC circuitry and the limits are 100 volts and 40 milliampere, it is under the limits. If the task need to be performed more than that, then we have to take into the consideration other possibility of applying some conditions there. 360 is about capacitors and capacitor banks. So normally we have capacitor installed in our electrical network. These capacitors have the function to perform. So when we are trying to establish an electrically safe work condition, these capacitor remains whole charge for a period of time. So it's necessary that we should have the proper strategy for de-energizing those capacitor, and we should take into the consideration how those capacitor will be discharged before starting any work there. So this article take into the consideration about establishing an electrically safe work condition for capacitor, and it relates to the requirements given in chapter number 1. So the limited approach boundary, restricted approach boundary, and the steps for establishing an electrically safe work condition for the capacitor and capacitor banks are same. So chapter number 1 is applicable to article 360. In 360.2, you will going to find different type of the definitions given related to arc blast, lead resistor, charge transfer, dielectric absorption. So arc blast is covered here, a source of possible injury or damage to health from energy deposit into occipital shock wave and high velocity shrapnel. So the definition which we discussed in starting related to the arc blast is not related to energy, but it's related to shock waves and high velocity sharpness, and it is calculated in pounds of feet square. There is a discharge time, that how much time the capacitor will going to take in order to discharge the stored energy which it has. So either we can use the ground stick method, in which we are grounding and shorting all the terminals and discharging the capacitor and capacitor banks, or we are using hard grounding. We can use hard grounding, the practice of discharging a capacitor through a low impedance, also called low Z impedance grounding, in which if the charge is stored by the capacitor is high, then we go with low impedance grounding so that maximum amount of charge is dissipated quickly. There is another definition related to hearing protection boundary. Just highlight this definition. It's a worker distance at which there is a 1% probability of air damage exists from 20 kilopascal shock waves. So hearing protection is related to work distance at which there is a chances of hearing damage is there. Then there is a lung protection boundary is also covered here. It's a working distance at which there is a 1% probability of lungs damage exists from 70 kilopascal shock waves or 10 psi. So in exam, they will go to check this knowledge, whether it's 50 kilopascal, 100 kilopascal, etc. Soft grounding, the practice of connecting a capacitor to ground through a power resistor to avoid the hazard related with the hard grounding. And time constant is basically the time it takes the voltage to drop by 73% during the discharge. So if the capacitor is charged by 100 volt, so how much time it will take for a capacitor to drop his voltage by 63%? So how much time it will take for a capacitor bank to reach to the voltage level of, for example, 27 volt in this case. Stored energy hazard threshold. These are the hazardous range given when we are dealing with capacitor and capacitor bank. So if we are dealing with less than 100 volts and greater than 100 joules of stored energy, if it's greater than or equal to 100 volts and greater than 1.0 joule of stored energy, greater than or equal to 400 volts and greater than 0.025 joules of stored energy. So you can see the relationship that as the voltage is increasing, the joules is decreasing. So basically this countered that and it basically established that what will be the amount of energy stored in the capacitor banks. Right. Then when you will further see this article, you will going to find that the steps for performance of the risk assessment. So the risk assessment procedure will be same as per the article 110.5 H3, in which we will be looking for elimination of the hazard or substitution control and other risk control which are identified in the hierarchy of risk control. Perform the arc flash risk assessment and the shock risk assessment will be performed as per the article 130.7. So arc flash PP, if questions come that if you are working with capacitor bank, how you will going to calculate the arc flash boundary and the PP requirements. So things related to article 130.7 will be applicable. So the method which we have covered in chapter number 1 will be applicable here. Right. For establishing an electrically safe work condition related to the capacitor and capacitor bank, so this will going to cover the same steps which we have covered in article 120. These steps will be the same. Determine all sources of electrical supply to the equipment. After properly interpreting the load, connect disconnect. We have to disconnect whenever possible. Visually verify the blades are open. Apply the log on and tag out. If bleed resistors or automatic discharge systems are applicable, wait the prescribed time for the capacitor to discharge to less than the thresholds. Then part number 6, verify that the capacitors are discharged. Part number 7, before and after each verification, determine that the test instrument is operating satisfactorily. So we have also verified. For series capacitor, the shortening wire shall be attached across each individual capacitor and two case. So then finally we will be shorting the terminals of the capacitor to make it safe, and the work can be performed. So these are the steps you will going to find for establishing an electric saver condition for the capacitor. Then the grounding sticks we can use if normally with the overhead line where there are capacitors connected. We are using grounding sticks to discharge any potential charges which might be stored on the overhead lines. Visual inspection is related to maintenance of the capacitor, whether there is some crack is there or there is some defects is there or not. So we can perform those visual inspections. Electrical testing is also a method to test whether the ground sticks are working correctly or not. So there is a range given that the ground stick shall capable of to test to verify the impedance is less than 0.1 ohms to ground every 2 years. So every 2 years we have to perform the test and have to measure that the grounding stick have the resistance less than 0.1 ohms, and that need to be tested every 2 years. So you just have to need to highlight these important values, so that if it is asked in future, you know about those values. Storage and disposable. Any residual charge from capacitor shall be removed by discharging before servicing or removal. So an uninstalled capacitor capable of storing 10 joules or greater at the rated voltage shall be short circuited with a conductor of the appropriate side, because if not, then there is a chances that the charges will be built up if it is disconnected. So these are some of the overview of chapter number 3. You can expect around 10 questions from chapter number 3 in the exam, and there are approximately 5 to 6 topics. So from each topics, you can expect around 2 questions. For example, 2 questions from electrolyte, 2 questions from battery and battery storage, 2 questions from lasers, 2 questions from capacitors, and 2 or 3 questions from research and development laboratory. So this is a small chapter. Just go through it and highlight the important values and dates, so that you may be able to answer in the exam easily. Right. Okay, I'm sharing with you people some practice Q&A. Please confirm if you can open and save. Yes, it is opening for you people. Okay, so you will going to find initially there are some questions which might have solved during the lecture as well. So 5960 questions you will be finding from the exam point of view, and other are the screenshots of the topic which we have discussed. So just read through the standard and try to solve these questions as a practice. And if you have any problem with the answer or with any clarification, just text me, or you can text on the group as well to have a further discussion. Okay. Right. So any confusion or any questions up till now related to the questionnaires, question exam, and other thing?
Assalamualaikum, sir.
Walaikum salam. Yes, please.
Yes, unfortunately, I was not able to attend your lectures. So I have received the shared lectures from Mr. Johar. So first question is about their sequence. I have been looking at the questions. Is there some simplified any sequence for those? If any of the colleague or you can share how to go with in an order.
Sequence of lecture or sequence of questions?
Lectures.
Okay, I will ask Mr. Johar to do it in a manner that it is, yani, if it is
1, 2, 3.
Yeah, that will be more.
This is one thing, sir. Secondly, is there any other questions resource for exam practice? Like normally they have.
No, for CSP, it's there is no bank available. These are the questions I have tried to collect from different training programs, training sources, and people who have went through the exam. They have come back that the discussion which we had in for chapter number 1, 2, those are more than enough to answer any type of the questions in exam. Chapter number 3 is more related to the bookish, so they are asking direct questions.
Okay, sir.
And those informations are available.
So the next step in if you are interested to book for an exam and all that, so what is the procedure like? Can like me?
Yeah, now you have to. Okay, Mubin has sent something. Session number 1, Wednesday, shared recording.
So yeah, the file that I made, these are actually the names of all the files that were being shared with the day number. So day 1 and day 5, I believe they're missing, and day 12 is yet to be uploaded.
Day 1, I sent you directly on the WhatsApp because because I think that was something which was not saved online, and I had shared on the WhatsApp. I will going to share again. Okay, so day 1 is there. Today is okay.
So your presentation is this accessible?
A presentation is accessible through the recordings which we have shared. So all the material and all the things are there, and I have shared a lot of material for you people to go through as well.
Okay, so sir, for exam, like we have to do it independently, or
yeah, for first you will go to NFPA website. You will going to create your account. Then once you have created your account, you will going to upload information like 40 hours of electrical safety training, which will be the certificate will be given by you, Mr. Johar. Right. In addition to that, you have to upload your degree, your bachelor's degree, okay, and your experience letter, that you have worked in this field for 4 years and more. Okay.
So for people like me, like I'm in having background from chemical engineering, but I have experience in electrical systems and all.
Yeah. So your degree will fall under, I think, table number 4. Other than electrical engineers, then you have to show around 6 years of experience or something like this with electrical system.
Okay.
So they normally accept. They don't do
Yeah, okay.
much Q&A. So once your application is accepted, they will ask you to pay the fees. Okay, so once you have paid the fees of, I think, $400 now, then they will going to give you a link for registering the exam.
Sir, is for NFPA 70E the other source is only the handbook or
No, the handbook is this one I'm talking about. This is related to the certification program.
yes.
So in this certification program, you have to follow this one, non-electrical engineer. So you have a bachelor's degree in engineering. Okay, then you have to show that you have 10 years of experience. No. With 3 years of verifiable experience with electrical power systems. So you can show that you have 3 years of experience dealing with electrical safety in your organization.
Okay. There is something under as well for 20,000 hours, 10 years.
This is for those who don't have any qualification.
Not bachelors.
Yeah, so it's only based on experience.
Okay.
So this is a handbook, and just go through the standard. Try to absorb the standard. If you have any questions, just put your Q&A on the chat, and then on the WhatsApp chat, we can have a continuous discussion.
So,
I have some question and answers of 2015 or 18 edition, but I believe that will going to make you people confused a bit. I will go to share those question and answers as well, but don't be because some concepts have changed from 2015 to and 18 to 2021. So if you don't find the right answer, just discuss that thing. So there are, I think, 100 questions there as well. Okay.
yes, sir.
Right. Any further questions?
Sir, I had some other questions related to the field, not specifically for the course.
Sorry.
Sometime I have questions, but not directly related with the course. I can,
Okay.
I can sum them up and then I can share it from the group.
Yeah, sure, please. No issues.
Okay, sir.
Right. Thank you all for joining. Keep in touch, and if you face any issues while reviewing the topic, just let me know. We can have a discussion. Okay.
Sir, one last thing. These lectures will be accessible, right? Is there some time limit for these files?
You have to download, I think. Don't keep it online. Just download. Yes, Mubin, have you been able to download?
I think there is some restriction.
I think the Johar Sahab has actually blocked it from being downloaded.
Yeah.
Then you have to talk to him. Okay. Just put it via IDM. You can download. So Janzev has given the solution, or otherwise you can talk to Mr. Johar.
Yeah. Okay, sir. Okay, sir. Thank you so much. I really missed your last lectures and I was unable to attend, but I was really missing them.
Yeah, it was due to change in timings, Ramzan and other things.